Okay, now let's see how we handle this question. Now here we are going to see what happens if you have more than 1 hinge. Two uniform rods AB and BC, each with length 2L and weight 20 newtons and 12 newtons, are hinged at B. So this is going to be our B. So if this is the hinge at B, it means that we have AB. So this one is going to be A. So there are going to be having A. Then you are going to be having B. I mean, you are going to be having C. So our C is going to act here. So this one you are going to be having C. Okay. So of course they are telling us that they are uniform. So this one is having weight of 20. So here I'm going to be having 20 newtons. And here I'm going to be having a weight of 30 newtons. So they are telling us that their length is 2L. This is 2L. So meaning, remember it's going to divide this into 2 equal length L. L. From here up here is 2L. From here up here is 2L. The ends AB and the ends A and C are each smoothly hinged at 2 points in the same horizontal line and they are distance 2L apart. So these ones are 2L apart. From here up here they are 2L. Okay? Find the horizontal and the vertical components at each hinge. Okay? We have this, and this. Now, this is 2L, this is 2L, and this is 2L. It means that that's an equilateral triangle. So it means that the angles are 60. So this is going to be 60 degrees. This one is going to be 60 degrees. And this is also going to be 60 degrees, like that, basically. So now, it means that if we have that, then we need to, because here this is the hinge, we are going to have a horizontal and the vertical component. So let us call this one C2 and we call this one X. Then this one here, we are going to be having, let us call it A2. This one is going to be X also. Why? Because for this to be in equilibrium and symmetric, it means that the X component and the X component, I mean the horizontal components in this line have to be the same and they are acting in opposite direction but they are the same. That's the idea we have there. Okay, so now after that I think we can see that this one we are going to be having this here. And then if I divide this into 2 parts, and also this one weight is going to be there. Why am I doing this? I want to get the length here. So if this is the hypotenuse, this is adjacent, it's going to be L cos 60. You say this and this have to be the same if you are dividing this into 2. So this is going to be also L cos 60. L cos 60. Now basically on this, because this is going to be also L, so this will be L cos 60. This and this are the same. Basically that's what we have there. So now we say there, the first thing, we have now these 2 moments here and here. How do we get them? We say we resolve vertically and then after we take moments. So resolving vertically upwards, I'm going to be adding A2 plus C2. They are the ones acting upwards. They are going to be equal in 2. This one is acting downwards. 20 newtons plus 30 newtons. Imply that my A2 plus C2 is going to be 50 newtons. I call this equation 1. Now, from there after, we take moments at, when we take moments at A, we shall get this C2. So take moments at A. So see this one is acting anti-clockwise. So I also take anti-clockwise. Now if I take moments at this, all forces from A, their moments are going to be 0. So we have the forces abiding this, this, and this. So means that now I have C2 times the perpendicular distance from here. I think we told us that from here up to here is that it's going to be 2L. Up to here, it's 2L. Sorry, just take 2L or you add this. Okay. Then add this. So I'm going to be having 4L cos 60 equaling 2. Now this force is acting vertically downwards. I think you can see we have this allowance, for it is going to act clockwise, even this one is going to act clockwise. So, using the principle of moments, anti-clockwise moments are equal to clockwise moments. So you have this one as 20 times, you see the complete distance from A is this to this force, I think you see. We have L cos 60, then plus 30 times the complete distance from here up to here. It's going to be this plus this up to here, which is 3L cos 60. Now start L cos 60 is common, we divide it throughout. L cos 60 is common. So here we are having 4C2 equaling to 20. So you are going to be having, this is going to be our 20 plus, this is going to be our 90. So we have 90 plus 10, that's 130. 90, sorry, this is 90 plus 10, that's 110. So our C2 is going to be it's going to be 27.5 newtons. That's our C2. So from one you can start our A2 is going to be 50 minus C2, which will be 50 minus 27.5. So it's that our A2 from here we have 22.5 newtons, as simple as that. Now, this is now we have got the vertical components for C and A. Now to get the rest, now we separate. So I separate. So separate body. We are going to be having two bodies. So separate body 1. So if I separate, now I'm going to consider this. So instead I separate this, I'm going to be having, now you see here the reaction here, I think you can see here. At B here, the reaction is going to be in this order. So this is going to be our R, this is going to be also our R. So where you take is where you get your answer from. So if now I take this one, my reaction is going to be active in this direction here, and then this at B. If you consider this, now it's going to act in that order. So if I take that, I'm going to be having this, then this acting in this side. That's where I'm going to be having. Now I'm taking this, so my reaction is going to be here. This is my B. So this is going to be my B. So I'm going to call this one B1. Then I call this one B2, the vertical components at B, because my reaction is going to be acting in that direction there. Then for this body element, I'll consider that in the next part. Remember, this is our X. This is going to be our A2, which we have already, but we have our weight, of course. Allow me to, okay, I have this like this. I want to form something so that this something here, from here up here. Okay, so remember I have my weight here. This weight is what? Is 20 newtons. So now we say what happens there? You just resolve. If we resolve, should I put it there? Okay, let me put it here. So if I resolve horizontally, instead I'm going to be having X equaling to, remember this one is going to decide. They are the only forces we are having horizontally. We're going to be having X this equaling to this because these bodies are in equilibrium. That's the basic we have. So here, then I resolve vertically upwards. I have, you see, A2 is going to be equaling to 20, then plus B2. And set my A2, I have A2 as 22.5 is equal to 20 plus B2. So you can ever set my B2 is going to be 2.5 newtons. So I have the horizontal component there. What happens if you want to get now this X component? We take moments at B. So So taking moments at B, I want to get these x components, so I'm going to take them anti-clockwise. So I'm going to be adding x now times the perpendicular distance from here up to here. I think you see that this one, basing on this is 2L sine 60. The perpendicular distance, if this is 60, from here up to here is 2L. So it means that if this is 2L, this is going to be, the perpendicular distance from here up to here is going to be 2L sine 60 degrees. Okay, now if I have that, remember this one is going to be having it's going to be L cos 60, then we have also L cos 60. These ones here up there. Okay, so from there I think you see I have 2L sine 60. It's the only, I think there you can see. If we on that, if we on B, this force is acting at clockwise, I think you can see. Then at B, I think it's where this one is going to act. It's going to act like that. Then this one at B, I think this one is also going to act anti-clockwise. So then plus 20 times the perpendicular distance from here up to here is the same as from here up to here. I think you can see the perpendicular distance from here up to here is the same as from here up to here, which is L cos 60 degrees, equaling to the only force we have which is going to act clockwise is this. So we have A2 times from here up to here. The perpendicular distance from here up to here is the same as from here up to here, which is 2L cos 60 degrees. Now, all forces from here are taking moments. Their moments are going to be 0. That's why this moment is going to be 0 for this and that. That's why I'm not considering them. So from here we have x times 2L times root 3 over 2 plus 20 times L times a half. Cos 60 is a half. This one, A2, we have already our A2 as 22.5 times 2L times a half. You see this one is going, this one by this is 10. So you see this one is going, our L is common. So basically, you can say we have root 3 x plus 10 equaling to the only thing surviving 22.5. So now my x from there. If I have to get my x, I'm going to get so I'm getting 7.2169 newtons. So this is my x components. So if you have x components, it means that we can get our B1. So our B1 is going to be also equal to 7.2169 newtons from this equation 3 from 3. Basically, we have that. So now we have the x component for this. We have the y component for this. We have B1. We have also B2. So we have also the hint there. Then separate body 2. Separate body 2. Now is when we consider this one inside, where we are adding in this case here. So here we are going to consider these forces. So here, remember, this is going to be my C2. This one is going to be my X. Now, remember this reaction, we said the reactions are the same but opposite in direction. So here at B, so if this is my B, so B here, now this one downwards, which is acting downwards, now it's going to act upwards. So I'm going to be adding B2. Then here, I'm going to be adding, this one was acting here, so this one is going to act. So here I'm having B1. So we have B1, we have B2, we have C2, we have X. So we have all the components. So this is my C here. So we can say at C, we can get the moments at C. Now you see we have X, our X is already, our X is 7.2169 newtons. Then our C2, we got it already as 27.5 newtons. So those are the components. Then I come at A. Let me get now at A. The components there are A2. My A2 is 22.5 newtons. Then what else? My X is 27. Sorry, it is 7.216 newtons. Then I come lastly at B. What do I have at B? At B I have my B2. My B2 is where? 2.5 newtons. Then B1 is going to be 7.2169 newtons. So those are the horizontal and vertical components at each hinge. So basically, that's how we had to handle that number. And that's it. I think we have seen all cases. This was the only missing case. That's it, members. I wish you well.